Esteemed scholars, welcome. We are continuing with the discussion on inequalities by looking at yet another example. Thank you for continuing to like our videos. Thank you for continuing to share them. Thank you for your continuous subscription. Don't forget, inequalities is the state of two things not being equal. To solve inequality questions, we use the usual algebraic processes, except that we must remember to change the inequality sign when dividing by negative constant or when multiplying by negative constant. Let us look at this example. What is the truth value of 1 minus 3x greater than or equal to 10? Truth value is simply saying what is the solution set of 1 minus 3x greater than or equal to 10. The Roman figure 2 shows the truth value on a lumbar line. In other words, illustrate the solution to this inequality on a number line or a line graph. We are going to do it in two ways, and I would love you to pay undivided attention, please, so that whichever is more convenient for you is what you will use under an exam condition. Now, I am doing it in two ways. We want to find the truth value of 1 minus 3x greater than or equal to 10. Now, way number 1 is to collect like terms by moving 1 to the right hand side. So that will give us minus 3x greater than or equal to 10. If you move plus 1 to the right, it becomes minus 1. If we don't do it like that, what's the other way of doing it? Move this negative minus the negative 3x, move it to the right hand side. That will give you 1 greater than or equal to 10 plus 3x. Now, in this first approach, carry out the subtraction. That will give us 3x greater than or equal to 10 minus 1, of course, is 9. Or, on the other hand, move 10 to the left hand side. That will give us 1. 10 is plus 10. When it crosses over to the left hand side, the positive sign will change to negative. That will give us minus 10 greater than or equal to 3x. Of course, all we need to do here now is to divide both sides by the coefficient, which is minus 3. Remember, division by a negative coefficient will reverse the inequality sign. That will give us minus 3x over minus 3 greater than will be reversed to less than. Then of course, the equal to remains equal to 9 over minus 3. Or, here we do the subtraction. 1 minus 10 is minus 9 greater than or equal to 3x. Minus 3 would cancel minus 3, leaving us with x less than or equal to, of course, there's a positive sign in front of 9. That's why it's not shown. Plus divided by minus, minus. 9 divided by 3, of course, is 3. Or, so over here now, we are going to divide both sides by the coefficient. But the coefficient here is plus 3. The inequality sign will not be reversed. That will give us minus 9 over 3 greater than or equal to 3x over 3. Of course, we already have the answer here. It remains x less than or equal to minus 3. Or, now there's a positive sign in front of 3. So we are dealing with minus divided by plus. Of course, it's minus. 9 divided by 3 is 3. greater than or equal to what's 3x divided by 3? Of course, it's x. We can draw our number line with this because the letter is already on the left while the constant number is on the right. But we can't do the same with that. So therefore means that we must bring the letter to the left and take the constant number to the right. So doing that will give us, now if minus 3 is greater than or equal to x, meaning minus 3 is more than or equal to x, it naturally follows that 3 is less than or equal to s rather is less than or equal to minus 3. So when we bring s to the left, s is less than minus 3 because minus 3 is greater. So s is less than or equal to minus 3. By comparison, you now see that both answers are the same. What therefore is our truth value? Our truth value is s less than or equal to minus 3. Pay attention. When you are taking the entire content on the right and you are bringing it to the left, and you are taking the entire content on the left and you are taking it to the right, the inequality is also reversed from greater than or equal to less than or equal to. If there were less than or equal to before, it would have become greater than or equal to here. Now we can take Roman figure 2, which is asking us to illustrate on a number line. Don't forget that our number line is an x-axis that is graduated and that is bearing an arrowhead. Here let us have minus 6, we are graduating, minus 5, minus 4, minus 3, minus 2, minus 1, and of course 0. What is the rule to graduating an x-axis? Just ensure that the value in the solution set is visible on your number line. That's all. Because everything revolves around that value. In this case, it's minus 3. And we can see minus 3 on our number line. The boot of the arrow will sit on minus 3. But the inequality is a general one, less than or equal to. The boot will be shaded. You may use any shading style that you like. Finally, less than faces the left. The arrow will face the left as long or short as you want. Scholar, you are the one that determines the length of your arrow, but it is the solution set or truth value that determines the position of the boot of the arrow. And of course, you will tell me now that this thing is as easy as ABC. I agree with you. It's even simpler than that. But to test just how much we have grasped, let us look at a single speed work, or if you like, classwork. How will I get your attempt? Send it to me through the comment section, and I will be glad to assess it for you. Let's look at the classwork now. It's going to be a single question. Solve 1 minus s less than or equal to minus 5. Illustrating the truth set on a line graph. Don't forget that If you would ever need to divide or multiply by a negative constant, that will reverse the inequality sign. This is how much we are going to go on inequalities, and I'm very sure that we have added values to you. We would like you to share our videos. We would like you to subscribe to our channel, and of course we implore you to continue to like them or repost them. We'll see you in the next video, esteemed scholar. Thank you.